Hello guys, welcome back. So today we're going to look at the concept of factor and remainder theorem. Now essentially they are kind of the same thing, but we are going to just kind of look at it in more details on what exactly is factor and what is exactly a remainder theorem and how do you apply it. Okay, so I think the best way to look at it is let's look at an example. Yeah, okay. So let's say I have a polynomial x squared minus 3x minus 4. And I'm going to divide that with, let's say, x plus 1. Okay? Now, I'm not sure if this is going to be a factor, x plus 1 or not, right? But what I know is this. In general, we say that the original polynomial will always be equals to the quotient multiplied by the divisor, let's say in the form of x minus a, and it has a remainder plus r. Now, if it's a factor, think about it. Like for example, if you do 8 divided by 4, you get 2, right? Now, we would say that 4 is a factor of 8, right? Now, if the divisor is a factor, then you will see that there's no remainder. Okay, you will see that there's no remainder. And this is exactly the same when applied to factor theorem. So if this is true, if x minus a is a factor, then you would expect that r to be equals to 0. Okay? And how do you kind of find r then? It's very simple. You want to sub a value that will make this divisor 0. And in this case, I'm going to sub a to the x. All right, so in essence, what's going to happen is that you're going to have FA equals to QA times 0 plus R. And you notice that whatever QA is, some value, when you multiply by 0, you will get 0. And what you're left with is FA equals to R. And if R is equals to 0, then we can conclude that x minus a is a factor. Okay. Now we're going to try that for this example. All right, we're going to let fx be equals to x squared minus 3x minus 4, and we're going to replace x to be equals to minus 1. Yeah, we're going to sub that in and we're going to see what happens. All right, so this will be negative 1 whole square minus 3 minus 1 minus 4. So this will be 1 plus 3, which is 4, minus 4 equals to 0. So our remainder in this case is 0. And what we will conclude is that therefore, x plus 1 is a factor. Okay? So that's how we apply factor theorem. Okay, I'm going to put a highlight here to let you know that we are done with that. Okay, so now let's apply the same concept to remainder theorem. Now, the difference is that for remainder theorem, your remainder will not be 0. All right? That means the divisor is not really a factor of the polynomial. All right, so let's try the same example. Let's try x squared minus 3x minus 4. But this time around, I'm going to divide that with x minus 3. And what is the whole process of remainder theorem is to help me find the remainder. So what is the remainder? All right, so let's work that out. So very similar to factor theorem, I'm going to let x minus 3 to be equals to 0. Therefore, x is equals to 3. All right, and I'm going to let fx be x squared minus 3x minus 4. And what I'm going to do, I'm going to substitute 3 into the f. Right, which is 3 squared minus 3 minus 4. So that would be 9 minus 9 minus 4, which is equals to negative 4. So what is this negative 4? This negative 4 is my remainder. Very similar to the concept that we have just done here, right? Just done here. Except that this time around, your r is not 0. So if fa gives you r, and r is not equal to 0, therefore x minus a is not a factor, all right, and R is your remainder. So therefore we say the remainder in this example is equals to -4. All right, so that we are done with remainder theorem. So I hope that's clear on how we apply remainder and factor theorem. Yeah, so just remember, factor theorem, when you divide by a divisor that is a factor, your remainder will be 0. All right, and if it's not a factor, like in the example we've done, x minus 3, if it's not a factor, you do expect a remainder value. In this case, it's the -4. Yeah, so that is basically a recap of factor and remainder theorem. I hope that's clear. All right, cheers.